Okay, hi everyone. We're going to be starting where we left off yesterday. I believe we just finished this problem down here, number 17. So, just a quick recap. When we divide by a fraction, we multiply by its reciprocal. So, I'll do 17 again. This 2/3 is attached to our variable with multiplication. And if we want to divide, because that's the inverse of multiplication, we're going to want to actually multiply, because it's a fraction, by 3/2. So we take 3/2, we squeeze it in there, 3/2 times 2/3, and we have 3/2 times your 48. So on the left side, this is just gone. Go ahead and draw your wall. On the left side, the 3/2 and the 2/3 cancel out because you are multiplying by the reciprocal. So you're just left with 1x, and then you have 48 times 3/2. Now, if you want, you can just multiply across the top and the bottom. 48 times 3 across that way, and then 2 times 1 times that way, and then reduce. I'm going to reduce early diagonally because I know I can divide a 48 by 2, and that's going to give me 24. So I have 24 over 1 times 3 over 1. And then I can say, oh, hey, that means x is just, oh, you know what? I don't remember. I have to actually put this in my calculator. I'm recording this a little late at night. There we go, 72. Oh, my goodness. 72. And we should plug that back in to double check that that answer is correct. We should always check our answer. So we have 2/3 times 72 should be equal to 48. And we're going to do the same thing we did before. This is 2/3 times 72. So what we're going to do is reduce diagonally again. That's 72 divided by that 3. You have 2 over, well, 3 divided by 3 is 1, and 72 divided by 3 is 24 over 1. So what we really end up with is 2 times 24, which is 48, and then 1 times 1 is 1. So we end up with 48 equals 48. Same idea for 18. Now, 18, I'm going to show you two different ways to do it. Our variable is w. So we're going to want to get rid of this negative 1/3. So we want to divide by negative 1/3. And we'll real quick, we'll come over here and say, hey, if I have negative 1/3, its reciprocal is negative. Well, you flip it around, negative 3 over 1. So you're going to take this, and you're going to say, I'm going to multiply by negative 3 over 1, and multiply by negative 3 over 1. So on the right-hand side, you're multiplying by its reciprocal. It's just 1. Every single time you multiply any fraction by its reciprocal, you should get 1. So you have 1w, which we just write as w. And then the left-hand side, you have negative 3 over 1 times 7. And that 7 is a 7 over 1. So in this case, you can just multiply across the top and the bottom. So negative 21, well, over 1 is just negative 21. And that's your answer. So if you wanted to check your answer, what you can do is plug it back in. Say 7 is equal to negative 1/3. And then we said our w is negative 21. Remember, when you're substituting, you should always replace it in parentheses. I didn't just write negative 21. I wrote negative 21 in those parentheses. So we have 7 is equal to, well, I can actually divide negative 21 and 3. So, and I end up with, go figure, 7. This does end up working out. We're good. A couple more, and then I'm actually going to go all the way back up here real quick. Let's see. What would be a good one to do? I think 19 is a perfectly good example. So we have this negative 4/5. The reciprocal, if you want, just keep coming over here and say, hey, what's the reciprocal of negative 4/5? Well, this is going to become, we flip it around, negative 5/4. And that's what we're going to multiply by. We multiply this by negative 5/4. You know what? I'm going to zoom in a little bit. There we go. And I'm going to multiply this by negative 5/4 as well. And I'm just going to rewrite it really quick. So I have negative 5/4 times 60 is equal to, I'm multiplying by the reciprocal. That's just going to get me 1. I have 1k, which is just k. This is what happens every time you multiply a fraction by its reciprocal. You get 1. The reciprocal is the inverse, so you're supposed to just get 1. So again, we're just multiplying these fractions together, and I see I can reduce before I go ahead and multiply. So I'm going to take 60, I'm going to divide it by 4, and then I have 4, and I'm going to divide it by 4. Well, 4 divided by 4 is just 1. 60 divided by 4 is just 60 divided by 2, and then that divided by 2. So 60 divided by 2 is about 30. 30 divided by 2 is about 15. Oh, you know what? Caden's going to yell at me. I didn't even draw my wall. Oh, man. Oh, geez. Okay. So then we come down, and we are going to multiply across the top, multiply across the bottom. So you have, what is this? Negative, let's see, 15 times 5. That's a 25 right there, and that's a 50. So we should end up with 75. So negative 75 is what k is. I don't know why I wrote 2 negative signs. There we go. Right, sometimes I forget. Okay. We should always check our answer, double check. We should see, hey, if I plug in negative 75 like this in parentheses, remember, always parentheses, am I going to end up with 60? And the nice thing is we have a little indicator. We have 2 negatives, and we see that our answer is supposed to be positive. This is a good sign. If you only had 1 negative, something went wrong here. But because we have 2 negatives and we're multiplying them, they're going to cancel each other out, and we end up with a positive. So we can just keep on keeping on, finish this problem up. I can reduce 75 and 5. And you know what? Again, I just don't remember that one. I truly don't. 75 and 5, that's about 15. Oh, of course it's 15 because of this guy over here, duh. So we have negative 4 over, well, 5 divided by 5 is 1. 75 divided by 5, well, we just figured that out. That was 15. And then we keep on going. And we say, hey, look, multiply across the top, multiply across the top, multiply across the bottom. This is a 15 over 1, so our denominator is just going to be 1, which means we really just end up with whatever's in the numerator up in the top. So 4 15s, that's about 60, and the negatives cancel each other out, so we're good. So for number 20, what I want to do, I want to show you another way you can solve these. If you have a 1/4 out front, let's look at the reciprocal of 1/4 and see what we would normally do. Well, flip it around, you get 4 over 1. But don't we know that 4 over 1 is really just 4? Because 4 divided by 1 is just 4. So what we're going to do is actually this time just multiply by 4. Multiply both sides by 4. Draw your wall so you don't get yelled at. And then, well, if you're multiplying by the reciprocal, this stuff is just gone. It cancels out. It turns into a 1, which means we're left with 1p. And then you have a negative 9 times 4, which is a negative 36. And you're done. You don't have to work with fractions all the time, especially when your fraction is something nice like 1/4 or 1/8 or 1 over something. That's all you have to really worry about is that denominator when the top, the numerator, is just 1. So here, we just need to now double check and make sure that our answer is right. So we have to have 1/4. We said p was negative 36. And we want to see if that's negative 9. Well, I can reduce these. I can divide both of these by 4. So I have 1 over, well, 4 divided by 4 is 1. And then negative 36 divided by 4 is negative 9. Oh, and look, this is a 1. We're multiplying it by your negative 9s. 1 times negative 9 is negative 9. We're good, and we're done. Okay, 21. I want you to give it a shot. Let's talk a little bit about 22. Now, 22, we've got this mixed number here. And, I mean, it's frustrating to work with mixed numbers sometimes because of the way they're set up. They're easy to understand in real life applications, but when we're doing these computations, especially by hand, it can be a little tricky. So what I recommend doing and what you should do is change it into an improper fraction. Take the denominator, multiply it by the guy out front. Ignore the negative. You don't need to worry about that right now. Ignore it. Pretend it's not there just while you're converting. So 3 times the 1, that gets you 3. You're going to add the 1. So you multiply, and then you add. So 3 times 1 is 3, plus 1 is 4. You have 4/3. Okay, now that you've got your improper fraction, you are going to want to bring back that negative sign, right? Because negative 1 and 1/3 is negative 4/3. They're the same value. You don't suddenly want a positive number, but you also don't want that negative affecting the way you convert into an improper fraction. So, and then we've got this 2r. Well, I mean, the nice thing is here we only have the 2 attached to the r. So we have this 2 attached with multiplication. So we're going to divide both sides. We're going to divide both sides. And over here, we're going to end up with negative 4/3. And then we're dividing by 2. Dividing by 2. And on the right side, you're dividing. So those 2's cancel out. You're left with 1r. If you divide by a 2, though, here's something. Here's what I want you to do. Here's how you can write this. You have negative 4/3. When you divide, you really multiply by its reciprocal. That's not just true for fractions. It's true kind of in general for anything. If you multiply or divide by a fraction, you are multiplying or dividing by its reciprocal. So just go through, and now you just have to multiply those fractions together. So you have, before we do that, we could actually reduce diagonally. So divide both of those by 2. 4 divided by 2 is 2. And then 2 divided by 2 is 1. So really, r is just negative 2/3. I'll let you check the answer on that one. 21 is yours. And I want you to give 23 a shot. Just give it a shot. We'll talk about it when we come back tomorrow, okay? I want to see where you end up with it. Now, coming back up to the top really quick, let's work with, say, 15. 15, no, actually, sorry. Let's work with 16. Now, 16 is the same type of problem. We have these mixed numbers here. So why don't we turn them into improper fractions first? You've got 2 times 8. That's 16, and we're going to add the 1 to it. That's 17/2. You've got 3 times 5. That's 15, plus 1 is 16. Okay, now we want this a. We want this a value right here. Well, that means we want to get rid of that 17/2. If it's a positive 17/2, you want to subtract 17/2 from both sides. So minus 17/2. On the left-hand side, 17/2 minus itself is nothing. It's 0. So you have a plus 0, which is just an a. And on the right-hand side, you have 16/3 minus 17/2. Now, you need common denominators. Come over to the side or come up here if you haven't written anything up here yet. Just find some room. Find some scratch paper. That's fine. And find something that 2 and 3 both are factors of. So I'm going to list my multiples of 2. 2, 4, 6, 8, 10. That's probably all we'll need. If you need more, just do more. That's okay. And then 3, 6. There you go. There it is. 6. So if you want to turn this guy into a denominator with 6, you are going to multiply the top and the bottom by 2. So you have a is equal to 16 times 2 is 32. 3 times 2 is 6. Okay, the right, this one, 17/2. You are going to have to multiply both of those by, let's see, 1, 2, 3 to get, in order to get your 6 in the bottom. So you take 17, you multiply it by 3. That's like 51. I'm going to double check that just to be sure. 17 times 3 is 51. And then 2 times 3 is 6. And then you just have common denominators. So you subtract 32 and 51. and you get about negative 19. And the bottom stays the same. When you multiply, or I'm sorry, when you add and subtract fractions, the denominator should stay the same. Now, we look at this and we go, oh, can I reduce this? No, you can't. 19 is a prime number, so you're done. That's it. You're good. Oh, I erased it, but you're good. Check your answer. Give it a shot. I want you to do 15, okay? So I want you to do 15, and I want you to do 21, and I want you to try 23. This one's a little tricky. The mixed number gets a little bit hectic, but I think you'll be okay. We'll talk about it on whenever we come back. Wednesday. That's when we're coming back. There we go. Okay. Hope you have a good rest of your day. Bye-bye.